All right, this is problem number 40, and let me say right off the bat that if I came across this problem on the exam, I would definitely attack it, mark it, and then come back to it at the end of the exam, and even then I would still probably have to guess. There's a lot going on here, a lot of different concepts to put together, but it's a good problem to study, so let's walk through it one piece at a time. We're given two companies, company A. There's a 60% chance there's no claim at all. But if there is a claim, it's going to be normally distributed with a mean of 10,000 and the standard variation of 2,000. And then company B, there's a 70% chance that there's no claim. But if there is a claim, that claim will be distributed, normally distributed with a mean of 9,000 and a standard deviation of 2,000. And we're asked to find the probability that company B has more claims than company A. So there's two different ways that could happen. So we'll call that scenario one. In that scenario, A doesn't have any claims, but B does have at least one claim. And it won't matter what the value is of that claim, it just matters that there is one because the value of A's claims are 0. So the probability of scenario one is A has no claim times B has one claim. So that's half the battle right there. But scenario two, of course, is a little bit more challenging. So in scenario two, both company A and company B have claims, but we need to know company B, how likely it is that the amount of the claims will be more for company B than it is for company A. So, first part is easy. They both have a claim. So company A has a claim times company B having a claim, and that's going to equal 0.12. We'll get back to that in a minute. Here's the challenging part of the problem. And it really relies on your understanding of how independent random normal variables work. And the fact that if you have two independent normal distributions and you add them together or subtract them in this case, the means are going to be added together or subtracted in this case, but the variances will be added together in both cases. So let me write out the equation that we're really solving here. We want to know the probability that company B has greater claims than company A. So that would be company B's distribution minus company A's distribution has got to be greater than 0. So let's sort of simplify along the lines of what I just said. It's the standard deviations are 2,000. So I'm going to rewrite this with the variances. Exact same equation, same means, but this time I'm just going to state my normal distribution with the variances instead of the standard deviations, because it's the variances that we can combine. Got to be greater than 0. Okay. Now, when you have two independent random normals, their means are added together, or because we are taking the difference, their means are going to be subtracted from one another. So this will simplify, or rather these two can be combined into a new normal distribution with a mean of negative 1,000 and a variance. So even though we're subtracting, the variance is still going to be summed. And the best reason I can give for that is that variance is a measure of spread. So whether we describe that spread as negative or positive, it doesn't really matter. And I'll do a little demonstration at the end to show why. So we want the sum of the variances in our new combined normal distribution. And now let's rewrite this again back with the standard deviation here instead of the variance. I'm really trying to show steps that the answer key leaves out, because I think that's helpful. Okay. All right, and now we can simplify this inside of our calculator, and you get about 2,828. So I'm going to restate my new random normal one more time. So we want to know at what point is this new normal distribution we've created by combining the two we were given, at what point is that going to be greater than 0? So now we can go to the z-score. Our z value will be the point that we care about, the value of x. So we want to know greater than 0, so we do 0 minus negative 1,000 over 28, and that is just about, so when you use our normal table, we really only care about the first 2 decimal places, right? We look up the tens place on the left column and the hundreds place on the right column, or the tens place on the vertical and the hundreds place on the horizontal. So we don't really care about anything beyond those 2, at least not when we're taking exam P. So this is our z-score, which is going to correspond to a probability. It's still on the screen. P of z equals 0.6368. So let's come over here, and I'm going to try to give some context for that. We have got a normal distribution, and this value here is when x is equal to 0. So maybe that's right about here or so, about 63% of the way over. This is where x equals 0, this value here. And we want to know when our normal is greater than 0. So even though the z-score gives us this area here, we want to know when x is greater than, when this value is greater than 0. So we want this area over here instead, which is just going to be the complement of this right here. So let me just restate this. The complement is just 1 minus this value for 0.3632. So I think at this point we're ready to put it all together. Scenario 1, there is an 18% chance that we have no claims for A, but some claims for B. And then for scenario 2, there is a 12% chance that we will have claims for both. And in the event that we have claims for both, there is about a 36% chance, we'll say, go ahead and write out the full decimal there. There is that much a percent chance that the claims for B will be greater than the claims for A. And of course, we can do the math there to get a final answer. And that would match answer choice D, about 223. So that's the final answer. One last thing to go back to the statement I had about the variance here, where we're subtracting the 2 independent random normals. How come we are going to end up subtracting the mean to get negative 1,000, but we're still adding or summing the variance? We'll say you did subtract the variances instead. You know what? That would really create a lot of confusion, because we would have 2,000 squared minus 2,000 squared, which would be 0, and that just wouldn't be correct. So I don't know. I thought I had a little insight to add there, but the truth is I don't. Again, I just go back to this notion that variance is a measure of spread. And we aren't talking about moving to the left of something or to the right of something, but both. How much spread do we have across the mean? So we want that spread to be summative, regardless of whether we were adding or subtracting. So I hope that's helpful. Again, very challenging problem. In fact, really pushes the boundaries of my own understanding as a guy who passed this exam, took probability, took statistics, and does actual mathematics for a living. This is a really good problem. It's worth studying. to understand all the bits and pieces of it, to increase your personal competency levels. But if you were to see something like this on the exam, this would be the sort of thing that you'd want to mark, save it till the end, and then use all remaining time you have on it in order to figure out. At least that would be me. That would be me. Maybe for you it's a much simpler problem, but for me it was very challenging. So, final answer D, and thank you for watching.